am Krishna Gorai, a BS in Electronic System student at IIT Madras. In this video, I will be demonstrating week 1 experiment, which is voltage transfer characteristics of NOT gate implemented using NAND gate. To perform this experiment, we need total 7 components. First one is the 7400 NAND gate IC. Second one is a potentiometer to vary the input voltage to the IC. And third one is a ADALM 1000 gate, which also known as M1K, to supply the power to our circuit and measure the input output voltages. Fourth is a breadboard where we are connecting the components. And fifth is connecting wires. We are required some wires to connect our components together. And six is a multimeter to check the continuity of our circuit and wirings. And seven is a computer with Pixel Pulse 2 software for visualizing the waveform of input output voltages and plotting the voltage transfer characteristics graph. Now let's look at our circuit. So we have connected the IC which has the VCC and ground pin with pin 14 and 7 respectively. So we have connection to pin 14 with the VCC rail and pin 7 with the ground rail with this orange and brown wire. And this potentiometer has 3 pins. One is connected to the VCC and the other terminal's pin is connected to the ground. And the middle terminal pin is connected to the pin 2 with this blue wire. And pin 1 of this IC is connected to the VCC rail with this orange wire. And we are checking the input voltage at pin 2 with this green wire, which is connected to the channel A of our ADALM kit. And we are checking the output voltage at pin 3 with this white wire, which is also connected to the channel B of our ADLM kit. And this red wire is connected to the VCC rail and other end is connected to the 5 volt. And the black wire is connected to the ground rail and other end connected to the ground. Before we perform the experiment, we need to ensure the circuit is correct. So to do the correction checking, we need to check the continuity of our circuit. So let's check the continuity of our circuit using this multimeter. As you can see, if we touch two probes each other, the red LEDs glow up and a beep sound. Let's check the VCC rail first. So one end we have to connect to the VCC rail, and we have to check now the connections from the VCC rail to any component. So let's check the continuity of this orange wire, which is connected to the one terminal of this potentiometer. As you can see, if we touch this with this, it will glow up and sounds beep. So let's check the pin 14 of this IC. As you can see, it is also okay. Let's check the pin 1. This is also okay. So now we have to check the ground connection. Let's check the ground connection, which are connected to this pin of this potentiometer and pin 7 of this IC. Yeah, okay. So now another continuity of this blue wire, which is connected the middle pin of this potentiometer with the pin 2 of this IC. As you can see, all wirings are fine. So now we can easily perform the experiment. Now let's connect the kit to our computer and see the input output voltages of this NAND gate IC. Now we can see that the input voltage is 0, which is the channel A. We have connected here the channel A with the green wire to the pin 2. And the channel B is the output of pin 3, which is connected to the channel B. We can see if we put the 0 volt to the input, the resultant output the pin 3 is 5 volt, which is high. So let's vary the input voltage by adjusting the potentiometer in clockwise direction. So we can see if we rotate the potentiometer clockwise, the input voltage at pin 2 is increasing and the output voltage at pin 3 is not changing. That means this is the noise which can handle the IC. If we still increase the value of input voltage at pin 2, we can see the output voltage is not changing. Now close to 2.5 volt, if we increase the input voltage above 2.5 volt, the output voltage is changing. We can see. Now if we increase more input voltage at pin 2, we can see the output voltage is changing abruptly. Now close to 3 volt input, the output voltage is abruptly changed to 0, which means logic 0 with above voltage of 3. So if we increase it till 5 volt, the output at pin 3 is at 0. We have take the readings of pin 1, 2, and 3 voltages. We have noted all this and plot the graph pin 3 output versus pin 2 as an input. We can see here the this region is the transition region. We cannot determine it is as low or high voltage, and this region is the high voltage output, and this region is low voltage output. And we have successfully plotted the voltage transfer characteristics of NAND gate as configured as NOT gate. We have verified how the output switches from high to low as the input crosses the threshold voltage, and understood the noise margin and transition regions concept. Thank you.